This is page 112 in your math journal. We're going to call this one Analyzing Data, Distributions, and Graphs. Let's just say data and graphs. Okay, a few terminologies that I would like you to know. The first one is a cluster. And a cluster is when a bunch of data is close together. Okay, a gap is when there is lots of space between data. And skewed. Skewed left means the majority of the data is on the left of the graph. So skewed right would mean that most of it is on the right of the graph. Okay, symmetric data. Means that it looks the same on each side, kind of like a butterfly. So you know what symmetrical means the graph is symmetrical. Okay, these I'm pretty sure we've talked about them enough in class. I just wanted to make sure you had these written down. You can talk about how there might be a gap between two numbers, or the numbers are clustered in this area. It's just a way to help us see where the majority of data is for us making decisions about something. Okay, now another one I want to talk about is choosing appropriate distribution. Okay, we learned about 3 different ways to show data. We learned about line plots, we learned about histograms, and we learned about box plots. So when you want to use a line plot, it's when you want to see individual data here is when you want to see them in categories. So here's where, remember, we placed them into different categories and then made a bar graph based on that. And box plots is when you need to see spread or variability. Okay, from a line plot, you can easily find the mean, median, and mode. This just helps you see more general information, general grouping. And this helps you see more range, interquartile range. So by using these, it depends on what you're trying to see. One other one that we have, so I want you to draw a little squiggle line here. Okay, line graphs and bar graphs. Line graph is usually over time. So you want to see data over time. A bar graph is kind of like a histogram. It's usually though when you have more qualitative data. So these ones up here use quantitative data. So remember, this is when you have numbers as your outcomes. Qualitative data is when you have like, what's your favorite color? You get data, you can see how many people chose something, but your answer is not a number. This one can kind of be either or, but it's usually numbers. Okay, and one thing I wanted to do was how to read a line graph. So we're going to create a line graph really fast. If we have a table, we're going to show data over time. So let's say this is a concert. So this is the week number, and this is people that came to the concert. So week 1, there were 2,400 people. Week 2, they had 1,800 people. Week 3, they had 900 people. Week 4, they had 2,100 people. Week 5, they had 1,500 people. So if we were making a graph of this, this would be my x-axis. So time be on the x-axis. And people would be the y-axis. So week, number, and people. Let's give it a title. We could title this People at Concert. Okay, we need to go up to 2,400. So let's see how many lines we got here. 1, 2, 3, 4, 5, 6. If I count by 600s, 600, 8, 1,200, or maybe 500. 500, 1,000, 1. Yeah, let's do that. So 500, 1,000, 1,500, 2,000, 2,500, 3,000. Okay. Week 1, week 2, week 3, week 4, week 5. Okay, now as I graph these, to help us analyze this data, we're looking at how much things changed. $900 be about right here. So it looks like their concert attendance was dropping. But then it picked up again. Well, if you were the company running the concert, you'd look at why that happened. Well, maybe that was the weekend, Easter weekend, and everybody went somewhere else or something like that. You're just trying to see what's happening over time and why it's doing that. Okay, well, with the line graph, you then connect the dots, just showing how much it changes over time. And then they might ask you questions about it. But I'm pretty sure you're familiar with these, so I thought I'd just review over it.